Some features that acids identify with are they are sour tasting, are corrosive, release free hydrogen ions in water solutions. When reacting with metal, they form hydrogen gas, have a pH lower than 7, and turn blue litmus paper red.
Acids are chemicals which contain the element of hydrogen, more than that of pure water, in combination with other non-metals. Acids can be broken down into two categories. Strong acids, for example hydrochloric acid and sulfuric acid. These are the substances that enable the hydrogen ion to break away very easily. There are also weak acids, for example acetic acid and carbonic acid, which therefore hold on to their hydrogen ion and very little hydrogen breaks away.
A base is a substance which contains higher potential to accept rather than release hydrogen, like acids. Because bases are the opposite of acids, and bases having the potential to accept those hydrogen ions, bases can be used to neutralize acids. Bases that are soluble in water are called alkalis.
A corrosive substance is one that will destroy and damage other substances with which it comes into contact with. Corrosion is also the deterioration of materials by chemical interaction. It is known to also irritate and affect human skin.
Wait, so what is neutralization?
Well,
As said by Google.com, neutralization is defined as making something ineffective by applying an opposite force or effect. Thus, in terms of chemistry, acids and bases are able to neutralize each other. This is the case as when an acid and a base react with each other, the products are water, salts, and rarely gas. These are all neutral. An example of a common neutralization reaction was that between hydrochloric acid and sodium hydroxide, which when written in an equation looks like hydrochloric acid plus sodium hydroxide turns into sodium chloride plus water. But this doesn't give the full image of where each element goes during the reaction, as seen through a simple equation, HCl plus NaOH equals NaCl plus H2O. You can observe that this is a neutralization, as the elements have been rearranged to create the final products that are neutral, a pH level of 7. Farmers use calcium oxide, also known as lime, to neutralize the soils. If farmers fail to neutralize their soil, it will severely dampen the ability of the crops to grow properly, thus damaging food production and their income. Another example is that of the use of chlorine in pools in the pool industry, which react with the pool's water to produce hypochlorous acid, which allow for a hygienic pool in the 7.2 to 7.8 pH range that is rid of dangerous bacteria. If the pH exceeds this range, it causes an influx and growth of bacteria. Thus, more chlorine, which means more hypochlorous acid, will have to be added to account for and neutralize the extra bases that are causing it to drift the pH towards the higher end base levels, e.g. 14 pH. Now, before a food can even enter your body, the industry of cooking heavily relies on neutralization reactions with many cooking tasks, such as preservation and baking. An example of this is self-rising flour. Self-rising flour contains an acid and the baking soda, a base, that react with each other when milk or water is added. This reduces carbon dioxide, which causes it to rise when heated, creating delicious things like cake that we all love and people earn a living off.
So that's neutralization.
Yeah, it's pretty cool.
Sure is.